Welcome back. We'll now move on to our next lesson, which is annotating point plots with models. In other words, what we're going to do is to take a point plot and then add a model on top of it. Shortly, we'll discuss what we mean by a model. Okay. Now, so far, what we have done is we have learned about point plots, which plot the original data, and then we talked about how we can take a look at the distribution of a single variable by using a violin plot. So here we've got a violin plot of this particular measurement right here. Okay. Now, of course, what this plot is telling us is that the points range in value all the way from here, which is like a little less than 1, all the way up to, let's say, 3.5 or 5.5. Okay. So you've got some variable and all of its values fall within this particular range of, let's say, 1 to 5.5. That's the entire range. Okay. Now that doesn't mean that the values are uniformly distributed within that range. Okay. It is very possible that a lot of values are crunched up or crowded up in a certain area and very few values fall outside of that area. On the other hand, it could also be the case that the values are uniformly distributed across the entire range. Okay, that is what is known as the distribution of a variable. Now, what the violin plot does is it helps us to visualize where the points are more densely crowded and where the points are much less densely crowded. So from this point plot, we can see that many of the values are right here because that is where the violin is fattest. Okay, so this is telling you the density of points here is very large. This being narrow tells you that the density of points here is very few. In other words, very few observations are falling here. Lots and lots of observations are falling here. In fact, the maximum number of observations are falling there. Somewhere between, let's say, around 1.5-ish. Okay, so that's what the violin plot helps us to visualize, the overall distribution. Now, in this lesson, what we are going to do is we are going to take a look at point plots of two variables. Okay, here we took a point plot of a single variable and then visualized it with a violin annotation. Now what we are going to do is to look at point plots of two variables, which means there will be one variable on the x-axis called as the explanatory variable and another variable on the y-axis called as the outcome variable. Okay, so we'll first do a point plot of those two variables and then we'll annotate the point plot with what we call as a model. Okay, so the model is going to look like this, like a band, and shortly we'll discuss what we mean by that. Okay, so first of all, let's get an intuition for statistical models. Okay, now what do we mean by model? Well, a model is some kind of a summarized representation of a reality. Okay, so in this example, you see a big house and then you see a model of the house. Okay, now clearly the model is not the house, it is just a model of the house. Okay, it is some sort of a simplified representation of the house. Okay, so it clearly is not an exact replica. Okay, first of all, it's not the same size. And secondly, it differs in quite a few details from the original. For example, the color is different. This particular house has bay windows and so on. This doesn't. This has 3 chimneys. This has only 2. Lots and lots of small such differences. However, it does capture some aspects of the model. Okay. For example, the number of floors is the same. And the general shape is the same. It's sort of thin and tall, and so on. Okay, so it might be useful for some purposes, not very useful for some other purposes. Okay, so it captures some essential features and it's sort of like a summary of the original, whatever it is modeling. Okay, so let's take a look at a point plot. Here's a point plot of the ankle sizes of certain people along with their wrist sizes. So every point represents the ankle size of some person and their wrist size. Okay, so let's try to understand what is the overall trend of this particular collection of points. Okay. Now, broadly speaking, one may say, well, the overall trend seems to be that this cloud of points is sort of sloping up and to the right. Okay. So it's going like that, up and to the right. Okay. Now, how can we, now in this case, it's somewhat obvious. In some other cases, it may not be very obvious. Okay. So what can we do to really be sure about the trend? Well, one thing we could do to capture that intuition is to just take a couple of points and connect them. So for example, you see a line 1 here that's connecting this point with that point, and then there's a line 2 which connects another different set of points, and then there's a line 3. Line 2 is there connecting those 2 points, 3 is connecting those 2 points, and 4 is connecting these 2 points. Okay? So now what we see is lines 1 and 3 represent pairs of points where the larger ankle size also represents a larger wrist size. Okay, so if you look at 1 here, okay, so this point has a higher ankle size, it also has a higher wrist size. Okay, similarly for line 3, that point has a higher ankle size and also a higher wrist size than the point at the other end of the line. Okay, so in both of these cases, a higher ankle size maps to a higher wrist size. Okay, but that's not the case with lines 2 and 4. Okay, in these two lines, the pairs of points, say take line number 2. Okay, so this point here at the end of the line has a higher ankle size than this other point. Okay, it has a higher ankle size than this point, but it has a lower wrist size. Okay, so this line is sloping downwards as we go to the right, whereas the first two lines were sloping upwards. Okay, and line number 4 is different, right? So this point has a higher ankle size, but the same wrist size. Okay, so lines 2 and 4 don't seem to represent what we think of as a general trend of the points of sloping upwards and to the right. Okay, so now given that you've got 4 lines, 2 of them represent one trend and 2 of them represent another trend, what do we do? How do we come to a conclusion? Well, what we could do is to connect pretty much all pairs of points. Of course, we're not going to do this because there are going to be a tremendous number. There's going to be a tremendous number of points. But if we did that, we will find that a large majority of lines represent points where the larger ankle size also goes with the larger wrist size. Okay, so that is what tells us that the trend is up and to the right, meaning higher ankle sizes also mean higher wrist sizes. Okay, and that's the general trend, whereas there are many exceptions to the trend in our data. Okay, so what we are trying to do in a statistical model is to capture this general trend of the behavior of these points. Okay, so that's an example of a statistical model. The points themselves are the original raw data, and the band is the model. Okay, and the band captures the general trend of all the points. Okay, it shows the plausible range of wrist sizes for a given ankle size. Okay, now we could have a model which is just one straight line. Okay, so this model would say, well, if I have somebody with a wrist size of 23.5, then to find the model value, I draw a line from 23.5 going all the way up to the line. Okay, and then from there I draw a horizontal line and see where it intersects the y-axis. Okay, so the model says that for a person whose ankle size is 23.5, the model says their wrist size is 16.6. That's the model's value for that. Okay, now clearly we can see that there are people with 23.5 ankle size with varying wrist sizes. Okay, but the model says, well, the best guess would be 16.6. Meaning, if you repeated this experiment many times with different samples, okay, and for every sample, if you looked at people who have 23.5 ankle size right? And they will have differing wrist sizes, but the number 16.6 will be the one that is closest to all those wrist sizes that you see for people with ankle sizes of 23.5. Okay, so in that sense, 16.6 is kind of the best guess for the wrist size of people with ankle size 23.5, and that's what the model says. Okay, now statisticians prefer not to give point estimates, that is a single value. Instead, they prefer to give a band or a range of values. Okay, so in this case, for a person with an ankle size of 23.5, the model is going to say, well, their wrist size will fall in this range of 16.4 to 16.8. Okay, now let's try to understand better what is this band? What is the band actually representing? Okay, statisticians prefer the second model, we have already said, because, well, whatever work we do in statistics, we are doing with a sample. Okay, so this straight line we got based on this sample. Okay, what is this straight line? This straight line is the line that is as close as possible to all of the lines, all of the points. Okay, so there are many points, and we can draw a line there which will be very close to these points, but it will be very far away from these points. Or we could draw a line here which will be very close to these points but far away from those points. Okay, so the best line is the one that is as close as possible to all of the points. That's what the best line is. Okay, now, but of course, if you work with a different sample, meaning, suppose you had a population of 1 million people. Okay, you took 1,000 people, that was your sample, and you drew a line. Now, if you take a different set of 1,000 people from the same sample, from the same population, you will get a different line. Okay, the line won't be exactly like this, it will be slightly different. Okay, that is why statisticians say, I'm not going to give you a single line, instead I'm going to give you a band. And the estimates will always be a range. Okay, so what does the band actually represent? What the band represents is, if you repeat this experiment many times with different samples, okay, then for each sample we'll get a different line, as we just discussed. But 95% of the lines will fit within this band. That's what the band represents. It says that if you repeat this experiment many times, 95% of the lines you get will fit within the band. Okay, and therefore, saying that a particular line is the model is not correct, because any one of those lines is a reasonable model because it also came from a sample. So it's not that one sample is somehow better than another sample, right? So that is why we give a band and say, look, the band represents the best estimate. Okay, so statisticians prefer the second model. Okay, now how do you generate this plot? It's very easy. We say anthro-F, which is the data set, and we say point plot, put wrist on the y-axis, put ankle on the x-axis. Okay, that's our formula expression. And then we say the annotation is a model. Earlier we had said the annotation was a violin. This time we are saying the annotation is a model. Once you do that, it does all the calculations and gives us the results. Okay, so in this course, what we are going to do is to not focus so much on the underlying mathematics of how this calculation was performed, how was it arrived at, but an intuition for what is this line, this band, what does it represent. We are more concerned about the meaning rather than the underlying mathematics. Okay, so that brings us to the end of this particular topic. And do answer the review questions on this topic before moving on to the next video.